Neurology video series, let's discuss about hydrocephalus. What is hydrocephalus? Hydrocephalus is when there is increased fluid production, or spinal fluid production, that is, cerebrospinal fluid production, leading to increased ventricular size in the brain, leading to hydrocephalus. So you see hydrocephalus basically on a scan. The ventricles look bigger and then they are supposed to be. And what does hydrocephalus do? It causes pressure on the frontal lobes of the brain, and it causes three signs. It causes difficulty walking. The person forgets how to walk. We call that gait apraxia. So they will be very slow to initiate their gait. They'll be very hesitant to take a step. Once they take a step, they're not so bad, but the walking is still affected. They can have incontinence of urine, not being able to control their urine, and finally they can have some memory issues. So those are the three features of hydrocephalus. The walking usually is affected first. What is the cause? Most of the times the cause is normal pressure hydrocephalus, which occurs because of spinal fluid production, which happens in usually older people, excess spinal fluid production, and we don't know why that happens. Sometimes there can be some tumors which press on the ventricles, causing an obstruction to the flow, leading to hydrocephalus, but that's relatively rare. It's almost always normal pressure hydrocephalus. So how do we diagnose the condition? We diagnose it by symptoms, which I mentioned were especially the walking, and then we can do a lumbar puncture. What we do by a lumbar puncture is withdraw spinal fluid and then see if the person's walking improves after the lumbar puncture. So that's how we gauge the response and see if this is indeed normal pressure hydrocephalus. And sometimes, occasionally, we can do more specialized testing like a cisternogram, but that's relatively low yield and very technically hard to do. The treatment, if there's hydrocephalus, is a shunt, a ventriculoperitoneal shunt, which drains the excess spinal fluid from the brain into their own abdomen, a ventricular peritoneal shunt. And it usually improves the symptoms right away. One caveat is if the cognitive issues have already set in, if the memory problems have set in, then even if you do the shunt, it probably will not reverse that. So you got to ideally tackle it before the memory problems set in, when it's just the walking and the incontinence of urine. There's another caveat. Sometimes the ventricles can look bigger. Often, in fact, the ventricles look bigger than they are, not because the person has hydrocephalus, because the rest of the brain is atrophied. And that actually is one of the most common radiological reads, far more than actual hydrocephalus. We call that hydrocephalus ex vacuo, and often happens in dementia. In dementia, when the rest of the brain is shrunken, the ventricles look bigger, not because they are bigger, but because they are bigger relative to the rest of the brain, and they just appear to be bigger, leading to the radiologist often saying that hydrocephalus cannot be ruled out. So as neurologists, it's our job to see if this is real or not real hydrocephalus, and if it is hydrocephalus, to see what's the cause and what can be done about it.